highly technical civilization. Electricity is generated at power stations. It supplies the energy required for lighting and operation of equipment in factories and industries. Industrial production depends on electricity. Modern electronic devices for information, broadcasting and communication also operate on electricity. Electric power drives locomotives for better and efficient operation. Lifts in offices operate on electric power. Medical electronics, which can now diagnose illnesses, operate on power. Electronics for entertainment and domestic work also require electric power. The operation of air conditioners also depends on electrical power. In large offices, various types of office automation equipment and computers cannot operate unless electrical supply is available. In our homes, the electric supply helps provide the light. It is required to operate various other home appliances as well. Here you see a thermal power station. It generates electricity for our consumption. The electric lines from the power station deliver power through high-tension cables to substations. The electrical power is converted to suit the requirements of our homes. The power is then supplied to our home for domestic use. Two wires are taken out from the mains and connected to the mains board in the home. This consists of the fuse, the meter, the main switch and distribution boxes. Connections to operate the different types of equipment in the home are supplied via these fuses. Fuses of different ratings are fixed on the distribution board for power equipment current ratings of 5 amperes and 15 amperes. The electric supply is 240 volts AC, 50 Hertz in our homes. The two wires, called live and neutral, supply the power. Television sets, light bulbs, fans, tube lights and other electrical appliances require 5 ampere current. Switches and fuses are always connected to the line wire. Fuses are used to protect the electrical circuit in case of overload. That is, if the current in the circuit exceeds the unit. If they are in the neutral, lamp and power sockets would be live when switches are off. An electric shock will be felt by touching the electric line when it is switched on. Fused plugs are used in the house wiring circuit for safe operation. The earth pin on a 3-pin plug is connected to the metal case of the appliance, which is joined to the earth by a path of almost zero resistance. These are wired as shown here and have their own cartridge fuses. Every device and appliance is connected in parallel, that is across the live and neutral. They receive the mains 240 volts AC. The live and neutral wires run in 2 complete strings round the house. Switches are fixed on a suitable board through which equipment like lamps, fans and television sets are connected. If the live wire touches the case, a large current passes to the earth and the fuse blows. Thus, it protects the wire from the fire. Loose wires may cause sparking and lead to fire. Defective insulation and loose, bare wire should not be left as such in any part of the electrical wiring system. Electrical switchboards are not often maintained properly. Too many loose wires and connections are made. The careless habit of not earthing plugs and fuses is often responsible for fires. Here you see an electric iron. You can observe how the cable is connected. A rubber grommet is placed at the point where the cable enters into the appliance. It protects the cable and prevents from being worn out. The 3 wires, namely live, neutral and earth, are connected to the socket inside. The earth pin is connected to the metal case of the appliance. The live and neutral wires are firmly connected to the pins of the socket. If the live wire touches the metal case, then a person may get a shock. But if the earth is connected, then a large current passes to the earth and blows the fuse in the circuit. Thus, the earth wire protects the person from shock in case the person touches the metal body of the equipment. Similarly, the shoe at the other end of the press should be connected with live, neutral and earth. The live wire is usually red, the neutral black and the earth is green. These wires should be fixed and tightened properly. If they are connected loosely, they may touch each other and cause a short circuit. After properly securing the wires in their places, the cover should again be tightened with screws. The plug can then be inserted into the main supply for operating the press. An immersion heater, which is used to heat water, may give a shock if the live wire touches the outer body of the heater. As water conducts electric current easily, one can get a severe shock if the water is touched accidentally. The earth wire should be connected properly and it should be checked thoroughly so that the earth is available. A room heater, which is used to heat rooms in a house during winter, operates on electric power. The heater is connected with a 3-pin plug. The body of the heater is made of metal. Therefore, it is essential that it has a proper earth connection. Loose, bare wires should not be left as such in any part of an electrical wiring circuit. In case there is a short circuit, that is, if the live and neutral wires touch one another, a large current passes to the earth and blows the fuse in the circuit. All the wires should be connected neatly and properly. The proper size of fuse wire should be used. There are various ratings of fuse wire. For example, for lighting circuits, fuse wires which can pass currents up to a limit of 5 amperes should be used. If thick wires are used, then the fuse will not blow and it may damage the equipment and burn the wires.
MCB, Miniature Circuit Breakers, is a modern alternative to a fuse.
They have the advantage of being instantly resettable by a switch or button and of breaking an overloaded circuit in less than 1/100th of a second. Proper insulated tools should be used while working with electrical equipment. If you are working with a 240 volts main supply, you should use insulated tools, otherwise you may get a severe shock. Whenever a connection is made by using two wires, the joint should be insulated by insulating the wires. If a person is standing on a wooden plank, he may experience a shock, but the current passing through the body and the wooden plank will be less. To be careful, a person working on electrical equipment should use rubber gloves and insulated tools. All the electrical equipment that we use in our homes or in a factory should be wired safely. Sparks at switches and heating appliances are the main causes of fires. Electric fires are best fought with a carbon dioxide or powder extinguisher. An electric current passing through the body causes electric shock. Harmful effects can be produced, especially on the heart, the muscles and the nervous system. The severity of the shock depends on the value of the current and the time for which it passes through the body. The value of the current passing through the body depends on the voltage applied to the body. If a voltage of 220 volts is touched by a man standing in direct contact with the earth, it will give a very high shock, which may cause death. If the man is standing on a wooden plank, he may experience a shock, but the current passing through the body and the wooden plank will be less. Even in this case, the current passing through the body could give a severe shock. If the shocked person is still touching live equipment, switch off the supply at once. If it is not possible to switch the supply off, pull the victim away using a dry, non-conducting cloth or a rubber mat or a wooden plank. Do not use your bare hands. Lay the person on a bed carefully and send for a qualified doctor. If the heart has stopped, try to restart it by striking the chest 3 times over the heart. If breathing has stopped, lay the patient on his back and clear any obstruction. Take a deep breath, opening the mouth wide, and blow into his lungs. Watch his chest rise and fall. If the patient is shocked but still breathing, keep him warm. Do not give any drinks. Touching a hot iron or heater may give shock or burns. Cool the affected part with water. When you are working with any type of electrical apparatus, observe safety precautions. The electrical equipment and tools should be handled carefully while working in a laboratory to prevent shock. Observation of safety precautions will help to prevent accidents. Mains plugs must be correctly connected to the outer cover of the cable secured by the cord grip and the correct fuse fixed. Cables to equipment should have a rubber grommet where they enter the metal case to prevent insulation wearing. Earthing regulations should be fulfilled by each consumer. The body of any electrical appliance should be connected to the earth pin in the socket. When you are working with any type of electrical apparatus, you should observe safety rules. Proper insulated tools should be used. Students who perform experiments in laboratories in their schools should try to understand the working of the instruments which they have to use. A multimeter, which can read voltage, current and resistance, is a useful instrument. Electrical and electronic equipment which works on 240 volts main supply should be handled carefully. The earthing of the equipment should be checked with a multimeter. If you have to replace a fuse, check the fuse for continuity and use a fuse of the proper rating. Also, check that the live point does not touch the body of the equipment. Proper tools which are covered by rubber lining should be used. Care should be taken when using the tools so that the uninsulated portion of the tool is not touched by hand. Do not use the same plug point to operate more than one equipment. Use an extension board to connect 2 or more devices for power. Soldering irons work on 240 volts AC lines. Therefore, you should be careful while soldering joints. You may get a shock or be burnt if you touch the hot end of the iron. Do not insert loose wires to operate a piece of electrical equipment. Always use a proper shoe. Check the connections before you use such a device. In factories, very often fire and other mishaps occur due to poor maintenance of electrical equipment and lack of proper upkeep of switchboards and electrical wiring. This may cause short circuits, which can endanger the life and health of workers. Protection from electric shocks can be ensured by observing safety measures and following correctly the regulations for the electric supply system in the factory.